let's talk about geometric series. There are two kinds of geometric series we're going to talk about. The first one is a finite geometric series, meaning it ends. So like example 7. This is a geometric series because I'm timesing by -1/2 each time. Should look familiar. We've already seen this series this lesson. And this series comes to a finite end. There's no ... at the end of it. That is a finite geometric series. Now, anytime you have a finite geometric series, this is the formula you use to find its sum, to add them all together. Now, this equation is on your reference sheet. You don't need to memorize it. You just need to remember what it's for, that it is for finite geometric sums. So let's try this equation. I'm going to copy it down on the next page. Now, first, we know we have to use this equation because it's a geometric series. I'm timesing by the same number over and over. And it's finite. It comes to an end. So it looks like all I need to know here is my first term, which is 5. I need to know r, which I'm timesing by -1/2 over and over. And I need to know n, how many terms I'm adding together. Now, we actually already figured that out for this problem from example 2c. We found out that this was the 11th term. So I have this. Now I just have to plug them all into my equation. So 5, 1 minus r, r is -1/2, to the n, which is 11, all over 1 minus -1/2. And honestly, I would suggest just typing all of that into your calculator as is, to get an answer of 3.335. So if I were to take all these fractions and add them together, this is what they're all going to add to. Now, the second kind of geometric series we're going to talk about is an infinite geometric series. Now, we didn't talk about infinite arithmetic series, because if you take an arithmetic series, 1, 3, 5, 7, 9, 11, that goes to infinity. If I add all these numbers together, I'm just going to add to infinity because they keep growing and they keep getting bigger and bigger and bigger and bigger. So we don't really talk about infinite arithmetic series because it doesn't really matter. They're always going to add to infinity or negative infinity, period. However, infinite geometric series sometimes don't go to infinity. And let's look at example 7 for this. Notice that in example 7, each time I'm adding on a smaller number. So this number is smaller than the one before it. This number is smaller than the one before it. This number is smaller than the one before it, and so on and so forth. So if this sequence went on forever and ever and ever and ever, I'm adding smaller and smaller and smaller numbers to it every single time. And since I'm adding smaller and smaller and smaller numbers to it every time, we say that it would converge. Meaning, if I start with a big number and I add smaller and smaller numbers, it's going to converge to a single answer, where eventually those smaller numbers that I'm adding become so insignificant they don't really matter because they're so small. So here's how we know if a geometric series is going to converge, adding smaller and smaller numbers every term, or the other word we have is diverge, adding bigger and bigger numbers every single time. The difference between them is what you're multiplying by every time in the geometric sequence. If your r is between -1 and +1, then your sequence will converge. If your r is bigger than +1 or bigger than -1, your sequence will diverge. So notice here our r was -1/2. -1/2 is between these numbers. That's why this sequence converges to a single answer. So when we're talking about infinite geometric series, the first thing we have to figure out is if it converges. If your infinite geometric series converges, so r is between -1 and 1, then you use this formula. If your infinite geometric series diverges, that means each number is just getting bigger and bigger and bigger each time. I'll give you an example. 2, 4, 8, 16, 32, 64, da-da-da-da-da. I'm timesing by 2 every time, so it is geometric. But if I go to add all these numbers together, these numbers are getting bigger every time I go to the next number. So that's diverging. I can't add those together because they're all just getting bigger. So if it diverges, your answer is DNE, or infinity, because you can't add the numbers that are just continuing to get bigger and bigger and bigger and bigger on you. So that's how we deal with infinite geometric series. First off, we find out if it converges or diverges. If it diverges, we say DNE. If it converges, we plug in this equation. And that all depends on what R is. So let's try that here. First things first, we need to figure out what R is. So in this one, R is -1/2. Timesing by -1/2 every time. So because this R is between -1 and 1, we can say that this converges. And because it converges, I can use this equation. To use that equation, by the way, that equation is on your reference sheet. You don't need to memorize it. I just need to know my first term and R and plug it in. 5/1 minus a -1/2. Simplify all that, gives me 10/3. So if I added these numbers together, because the numbers are getting smaller and smaller and smaller each time, eventually they're going to become so small that adding them is inconsequential. It doesn't really change our answer. So adding all those together is going to get closer and closer to 10/3 the more numbers we add together. Let's try this one. So this one is written in summation notation. However, I do notice that this is the explicit geometric formula, which means this is my first term and this is my R. So I have R is 3/2. That is greater than 1. So I say this diverges because it's greater than 1. And I can right away say DNE, done. Let's try C. So I have my first term and R, just like I did last time. This time, R is 2/3, which is converges. So we can say that that converges, and now we can use our equation. So let's just pull the equation from our reference sheet. Our first term is 3/2. Our R is 2/3. I plug all that in to get 9/2. So if I took all the infinite series of this and added them together, they're going to converge to a total of 9/2. So that is how we do geometric series. If they're finite, if they come to an end, we use this equation. If they are infinite, we have to find out if it converges or diverges. If it converges, we use this equation. In the next video, we're going to do some application problems, some story problems using this information about geometric series.